In this problem, it says a company's revenue earned from selling X items is given by the function r of x equals 480x, and their cost is given by the function c of x. So we are asked to write a function p of x that represents the company's profit from selling X items. And profit, if you remember, is revenue minus costs. So we'll substitute the expression for revenue, so 480x, for R, and the cost expression for C. And next, distribute this -1 to both terms inside the parentheses. And then we can write it in descending order. So p of x equals -2.5x squared plus 480x minus 2,110. So next we want to identify the vertical intercept of the function and write it as an ordered pair. Since our quadratic function is written in standard form, the y-intercept is c, the constant, in this case -2,110, which means if the company sells 0 items, they will lose $2,110. So next we'll graph the function and use the graph to answer the remaining parts of the question. So how many items must be sold in order to maximize the profit? And what is the maximum profit? And those answers can be found by locating the vertex of the quadratic, which is at a maximum. And so the first coordinate of the vertex represents the number of items, and the second represents the profit. And what is the minimum number of items that must be sold in order to make a profit? So first we're going to locate the x-intercepts, which show when the profit is 0. But for the profit to be positive, we would look at the part of the graph that's above the x-axis. Out of these two x-intercepts, we're going to look at the smaller one. If x is 4, the profit would still be negative. So when x is 5, the profit is positive. And therefore, the company must sell a minimum of 5 items to make a profit.